Our next speaker will be Joshua Giordano. I think the name Giordano is quite familiar in Asia countries, especially in Taiwan and Hong Kong. He's the managing director of energetics company. He's a specialist in power generation and energy efficiency technology. As when we first met, I say it's also the field I work in the past few years. And he lived in New York, Tokyo, and London, and he can speak very good Japanese. Oh, hopefully, next language will be Chinese. He's a graduate of Rutgers University and the New York Institute of Technology, where he studied energy and environmental management. It's a very important field and very hot topics nowadays. And he's going to give us a presentation on the title of mechanism of setting up an overseas demo project of a green product and the services. Let's welcome Mr. Giordano.
That's better. Good morning, everyone. It's good to see a very nice turnout. First and foremost, a big thank you to the Green Trade Office. I'm very pleased that they invited me to speak in front of this wonderful group. Let's start with our presentation. So we'll go through a brief introduction of myself and my company. I'd like to go through the market background for you. I'll go through a few slides. I think it's very important that everyone in the room tries to get a better understanding of the electricity market. Everyone in here is interested in and related to green products. A large part of that deals with electricity. And so again, I'll go through a few things to explain how world electricity markets have developed. We'll go into some of the green technologies that are being tested and rolled out into the market, and then some of the projects where these technologies are being combined, both with general green industry, with smart grid, and with green and low energy buildings. And the question and answer will wait until the panel just after. All right, just as a very brief introduction, the headquarters is in New York. This is the Woolworth building. This is the first green building from 100 years ago. They built the walls so thick. Oh, sorry. They built the walls so thick that it's impossible for any air to come in or out of this building. Being from New York, you'll have to first forgive me for my New York accent. If you don't understand me, please put your hand up and I'll repeat. Having said that, being from New York, I don't understand UK or British or European football, but I'm a big fan of the New York Yankees and baseball. And I have to say, first thing, I'm very happy that your Mr. Wang seems to be joining the Yankees again. I'm thanking you for this. My baseball year will be very, I think, interesting this year. We have a representative office in Tokyo. My original company when I got out of university was at Mitsubishi Corporation. We have a bit of a specific business between US, Europe, and the Japan market. Our consulting practices, first and foremost, is in energy. Most of this is related to electric power production, but that also means energy companies that are producing natural gas, coal, and more now the technology, including wind, renewables, fuel cell, and related technologies. And then finally, policy. We advise some groups in the US government, as well as many in Japan, including METI, NEDO, the Tokyo Commodity Exchange, and a number of others. We've worked, I won't go through too much of the detail, but we've worked in many countries throughout the world over energistics is the last 12 plus years or so, and very much looking furthermore to put a dot there on Taiwan. You can go through this on your own. I won't spend too much time. Just basically what we call a laundry list or a basic list of some of the technologies we've worked in, again, energy specific. We'll talk about some of these things today. All right, so having said that, let's jump into energy markets. Okay, first, most of what is going on with green buildings and with the smart grid is related to electricity deregulation. This has occurred in some countries around the world, but not all. I understand here in Taiwan, the main Taipower still owns the power generation, the transmission lines, distribution lines, and has all of the customers. Markets deregulated in the US and Europe in the early 1990s. What this did was allowed for anyone that wants to build a power plant, coal plant, gas plant, wind farm, or photovoltaic, to build their own power company. The laws forced the utility to allow anyone to use the transmission lines and to deliver power to their customer. Most of this occurred first on the wholesale business, so large power generators delivering power to large manufacturers. And one of the main purposes of this was to first reduce costs, hopefully, and then much more importantly, to understand the price of electricity. This is really critical, and I think it's something that you'll want to keep in mind. When you're selling a green product, when you're manufacturing a green product, what is the cost of the power that the person is using? And I'll give you a small example as to why this is important. It's my toaster example. How much does a toaster cost? Shouldn't cost too much, right? Maybe $20. If you buy a really fancy one, maybe $50, $80. If you make toast every day, depending on where you live, and New York is very expensive, I can pay $80 in electricity every year to make my toast. That can be many times the value of the product itself. So am I buying a toaster, or am I buying really the electricity, and I happen to be using it to make toast? What am I paying for, really? Right? So it's a way to say knowing where your pricing is quite critical. You can see this is an example. In the past, this entire region, this is the Midwest in the US, would have all been the same price, one color, for wholesale electricity. After deregulation, they started to calculate what is the exact value of electricity in different regions. And you can see on the top, this is for maybe noontime. When demand is very high, the price goes up. And this would be in the evening. And you can see the darker colors relate to more expensive pricing. Well, what happened after the markets deregulated? It inspired thousands and thousands of new companies in the US and Europe in particular. Both energy companies as well as companies trying to figure out how to reduce these costs, both for large industrial companies, commercial, and now, we'll talk a little bit today more and more for residential customers as well. And so new technologies, smart grid, again, green buildings, are all coming into play. This is just to show that when I talk about deregulation, it's not everywhere. Even in the US, it's state by state regulation and requirement. Mostly in the high-cost states in the East Coast, California and Texas, they're very open and deregulated. I can purchase electricity from anyone that is offering. I can buy very green energy, wind and solar only, or I can choose traditional, it will be a lower cost. But again, it's a lot of white states in the middle are not deregulated. Okay. What will the future look like in terms of pricing in this map? Well, we know, I'm sure everyone has seen charts like this, demand is only going to go up in the future. So efficiency and green products are only going to become more and more important. At the same time, I think for this slide, if you look at the green line, renewables, from 1990 to the estimate for 2035, the amount will, well, certainly more than double, probably about 3 times. That also has very, very important ramifications for the electricity market and green trading. Everyone knows that wind power and solar is very green, but it's also a bit unstable. Solar, obviously, you don't get beyond daylight hours. Wind energy, you get in an intermittent fashion, quite often at night. It's not controllable. And so there's a huge industry now as well that we'll talk about a little bit in working to balance all of the traditional power generation now with all of this new green energy. And then last but not least, it's a relatively serious subject, but worldwide, after, of course, Fukushima, many countries are now reconsidering their nuclear policy. This will, again, mean that, well, governments will have very difficult decisions to make, but it does also create a huge amount of opportunity for anyone that is looking into working in the green sector. Germany, for example, has shut 8 nuclear power plants. That has meant a huge amount of support for wind and PV, in Germany in particular. Japan will try to start up, it seems, their nuclear plants, but there's no guarantee. They also have a feed-in tariff now to allow more wind and more PV. So this map will certainly change and create opportunities. All right, so let's talk a little bit about some of the specific technologies that are coming into the market. So if you look all the way to the left, this is the past, but it's not too distant past. You can see all the way to the left a small power generator, to transmission lines, to substations. It's very simple. It's very straightforward. You can understand there's very little opportunity for any green innovation in this sort of situation. I think it's interesting if you look up top at the system operator, there's a little telephone. That's actually very accurate. I don't know if you're familiar, there was a blackout, large blackout in the eastern US, maybe about almost 10 years ago now, I would say. Part of the problem was that the grid operators were using little blue telephones like that one to try to communicate with each other. And just really was not a very efficient way to manage a power grid. Well, where are we now? Present, I would say, and again, this is very much for markets that are deregulated and are starting to bring in new technologies. We still have, of course, central power plants, transmission lines, but you can see wind on the bottom of this, and this is being fed in directly into the main power grid. So that's one big change, as well as photovoltaic. You can see the blue telephone is gone. That transmission control center and distribution control center, these are 2 huge new industries that have digitized communications and cooperation between control areas, between different utility companies that now are talking to each other much more quickly. Again, an example, I use Germany because it's in the center of Europe and they need to communicate with all of the surrounding companies. Czech Republic, for example, Denmark, Poland. And but the old telephone method did not work. There are many big software companies now providing a lot of interesting new tools to allow them to communicate their next day estimate of how much wind energy they might produce, how much solar energy they might produce. If you look now towards the substation as well, you can see both wind and solar on what we call the downstream side as well. And many countries around the world are promoting this sort of green power generation. But now if we look towards the future, things change quite drastically. And these are the technologies we'll talk about a little bit today and some of the projects we'll talk about as well. So if you look to the left, we have energy storage. This is a massive new industry. I know that Taiwan is really working very hard to create new energy storage opportunities. Around the world, both in research institutions, but now as a practical real business, there are many companies in the US and in Europe that are actually selling storage solutions. And that can be on, say, the data center side for more retail market, but also in the wholesale side for large power utilities. And again, this is all connected back to wind power and to photovoltaic, where you need the energy, maybe at the time that the wind is not available or the sun is not available. You can see storage in both locations. The distribution centers become much larger. Also, it's a little difficult to see, but there's also a space for electric vehicles. I personally think this is going to be a very revolutionary new area. You can already see Toyota and other companies are producing hybrid electric and full electric. I know that in Taiwan there's at least one company looking at this. But what I want to impress upon you is that electric vehicles are really, again, like the toaster. It's part of an electrical system. If you know the company Tesla, is that something people have heard of? Put your hand up, please, if you've... Yeah, just a few of you? Okay. I'll explain then. Tesla is an electric vehicle company in California. It's one of the more successful ones that have come out in the last few years. The CEO is a very energetic, dynamic person, and he has said that the car that he produces is not a car. It's a battery with wheels that he is producing. He understands the technology that he's trying to create as a battery. He understands the cost of the car is not in the tires or in the motor. It's going to be in the long-term cost of electricity that he's purchasing. And where it comes from, if we want to talk about green initiatives, it's very important where that electricity comes from, whether it's going to be wind, nuclear, solar, or another source. Okay, so if we start looking into the technologies that are going into these large-scale demonstration test projects, smart meters are the very first area, and my apologies, the slide is not too clear. But what I'll explain, the very first part of creating large-scale test projects is in communications. So if we think about how that, remember back to that other slide, the old system had a telephone, very poor communications. These smart meters, which are being rolled out worldwide, are allowing for two-way, yeah, if you see again that old blue phone in the past and the transmission control center. I think I've hit the wrong. Okay, sorry about that. Provides two-way communication between the utility company and the customer. Well, what does that do for us? At the very least, it allows the utility now to not have to send personnel and staff to each customer's home once per month. And that was the first reason that these were installed, just to save the utility money. But over time, they started to realize, well, wait a second, we can send a lot of data and information to the customer. For example, if electricity prices are very high, meaning there's a shortage of electricity, they can send a signal to the customer saying, noontime, 1 p.m., costs will be very high today. Please reduce your air conditioner. It creates a lot of stability in the grid. It means less chance for blackout. It means lower costs for the customer. It means lower costs for the utility company as well. I use this Itron meter as an example. It's a large company. They're very successful. They basically only do meters. They have a lot of competition from old traditional sources like GE and others. It's not a particularly complicated technology, but it is what we call an enabling technology. It's something that allows so many other technologies now to be brought into the system. Okay, energy storage. We mentioned this before. Wind and solar create what's called intermittent power. There's a concept you may be familiar with or maybe not, which is called frequency response. In the US, we use a 60 hertz frequency. In most of Europe, they'll use 50 hertz. In Japan, actually, they use both. The management of the stability of the grid is one of the main jobs of a utility company. If they save money, that's wonderful, and if they're green, that's wonderful. But if the lights go out, everyone will complain. It's bad for the economy, and so that's their number one priority, is to keep the lights on. At the same time, so many governments have pushed to install large amounts of renewable power. In the US, we have renewable portfolio standards, feed-in tariffs, etc. So this is an example of Extreme Power Corp. It's a large dry cell. These are being installed on, again, the wholesale side of the market. And these are used so that if the wind drops a bit, the power that is stored here can increase to keep everything at the right frequency and very, very stable. I'll mention this again because this entire industry did not exist a few years ago. It's a brand new industry. This company got a lot of venture capital funding, and they're doing quite well, I would say, overall, even in a difficult market where everything isn't yet clear politically. And you'll see more and more of these sorts of technologies at every different level. I used a wholesale utility level example. But you can see this all the way down from wholesale markets down to commercial buildings. We mentioned data centers. But even in residential markets, they're considering as well for households potentially putting batteries in where it makes sense. I'll mention one of the challenges for anyone that's in the research side in the room, obviously, is cost. Still, batteries are very, very expensive. This one is in the 1 to 10 megawatt range, quite large. Okay, building energy management systems. Now we're coming back into the commercial side of the business. In the past, the only types of energy management systems that really existed were, say, SCADA systems that managed large power plants and the production of the electricity from these. Over the years, buildings have started to look much more seriously at software systems that control all of the functions in a building. And most important here is what's called HVAC, so heating, ventilation, and air conditioning. That's a huge amount of energy consumption in a building. And it's very important not only for greening a building to use less electricity, but also for the comfort of the people who are utilizing the building. They don't want to both waste energy and make people uncomfortable in the building. And I can tell you in New York, we're very bad at this. So many offices, a classic example is they turn the air conditioner up too high in New York, and it forces the very thin ladies to put on a sweater and turn on the heater under their desk. So we're air conditioning the office and other people are heating the same office. It's absolutely ridiculous, but at the same time, whenever I see something that is not green and not efficient, it creates an opportunity for someone in this room to come up with a better solution. These energy management systems, again, the companies that exist here did not have this market some years ago. It just did not exist. Now, almost every large building, one of the main things that they look at is installing a management system for their buildings. They also try to make it more comprehensive these days, so security systems, things that I'm actually not too familiar with in terms of building management. I'm sure other people in the room understand this better. But they're also keeping data, and this is another important thing. The building's history and usage of energy. If they're using energy at a point where they don't think they should be, there may be a problem with some of, say, the mechanical devices. Right? Maybe some of the venting or the pumps aren't working properly if they start to see immediately an increase in energy usage when they shouldn't. So these are also very useful in managing your portfolio of equipment, knowing when to change it, knowing when a problem is starting before it gets really bad and you need to replace a whole air conditioning unit. And this is the area that I think might actually be, in a way, most exciting, and also the area that is most wide open for anyone that has some idea. If there are some young programmers in the room, this is your chance to make kind of a Google type of business. Most of these residential controls, and this is an example called Nest. It's also now very popular in the US. It's a digital thermostat. Well, a digital thermostat by itself isn't so interesting. Just the old-fashioned one analog with a needle worked fine. So they had to make it digital, but also make it usable and useful for the end consumer. So they started to try to include artificial intelligence, and this is caught on in a big way. They're trying to remember when you're home, when you're not home, what temperature you like. One of the really interesting features of this as well is that you can set this to say, I don't want to pay more than a certain amount of money this month for my heating and air conditioning bill. So let's say it's $200 US for this month in the summer. You can set the air conditioner to manage not just the temperature, but also your cost. It will lower your air conditioner and try to keep an average so that it doesn't go beyond what you want to spend. Now, you can override that. I'm sure there are people who get too hot and say, I don't care. I'll just spend the money. But this is the sort of thing, again, didn't exist just a couple of years ago. And now this company will do very, very well. It's gotten a lot of funding. Oops, sorry. Okay, and then the last technology example we have here that goes into the larger systems that we're going to show you. I'm very, very positive on is electric vehicle, and then a similar issue which is called vehicle to grid. So of course electric vehicles are massive consumers of energy. They're efficient because of course they're not using diesel or gasoline, which is very, very important. But at the same time, there is the opportunity, and what's being tested now is the ability to use the battery in the vehicle to send electricity back to the power utility. So in the middle of the day, when air conditioning load is very high, but no one is driving, they'll send electricity from the electric vehicle into the power grid to keep everything stable. It will also reduce costs during the day. The hope is to recharge the vehicle at night, where prices are low and where the grid is not too heavily loaded and where the utility is very comfortable. So you can see that yellow area at the top is what's called peak power. That's the time in the middle of the day where the utility is most stressed and where prices are highest. So utilizing AC/DC converters, you'll be able again to send electricity back. You can be paid for this as well. There should be a meter. And if you're taking electricity in the evening, you're paying a low cost. And if you're giving it back at noon, you should be making money. The utility will be paying you for doing this. Okay. You can go through if you're interested. I just wanted to give you a very basic list of just a few companies that have entered the market specifically due to the opportunities that the regulation has caused, and that are making smart meters, for example, inverters, and then demand response. I'll mention this briefly because you'll see this in the next slides. Demand response are programs that originated in the US and have now gone into Europe, where when the utility needs to reduce consumption, they will send a signal to buildings like this one, and they'll say, please reduce your consumption from, say, noon to 4 p.m., 4 hours. They give you a signal 1 day in advance. And what this does is, first, it creates a revenue stream for the building. The utility did not have to build a power plant because everyone is cooperating and reducing their consumption. From the last slide, that green area, that peak, the utility would usually build a whole power plant just to cover that noontime consumption, maybe only 2 or 3 days a year. There are many power plants throughout the world that only run a few days per year. And it's only because we have those few days where it's very hot and everyone turns on their air conditioner at the same time. These demand response programs pay you to reduce your consumption so that power plant doesn't have to be built. The other huge benefit is that it overall, again, stabilizes the grid. We're not hitting the maximum capacity of the power system. It keeps it just a little bit below. Companies are paid annually just to join the program, whether they reduce consumption or not, because again, we didn't have to build a power plant. Then, on those few days a year in the US, say 4 or 5 at most in New York in the summer, if you do reduce your demand, you also get paid depending on how much you reduce. That's the electricity that the power utility is not buying from some neighboring area at very high prices. Hugely successful. All of New York has basically already signed up for this. It's a state-by-state program. Europe understood that this is also very useful, and now on a country-by-country basis, UK, Germany, France, and others are also starting to bring these systems in. Okay, now how do a lot of these systems all tie together? So we've gone through a bit of the market and the idea that green also means reduction in financial cost. Then we've gone through some of the technologies, and now we'll look at just a little bit at how some of these technologies are being tied together. I'm going to say that with these large projects, whether it's smart grid or whether it's a green building or whether it's an electric vehicle, there is absolutely no clear rule or no absolute established framework for how these projects should work. It's absolutely based on the location, the specific needs of a community, what the government wants to support, and of course all of your ideas. because that's where all of this comes from, so the innovation. Okay, so I'll go through just very quickly. The US is spending a huge amount of money, both to support the greening of the US, but also they understand it's a very good opportunity for new jobs and new industry. We're talking many, many billions of dollars over the next few years overall. Europe, not to be outdone on a country-by-country basis, is also putting in quite a lot of money in both R&D and in demonstration projects as well. And then finally, I'm not sure of the exact figure in terms of spending in Japan, but they are active not only in Japan with their own smart grid projects, but they've also started to put projects together internationally. I've been involved in a number of them. The state of New Mexico has, this is about an $80 to $100 million test project. On Maui, they're doing an EV project, which we'll look at in a moment. Another electric vehicle project in Spain, and they're also in mainland. Okay, so here's our very first example. We have examples of both laboratory test work. Their lab is part of Fraunhofer Institute. They're very, very active in green technology, both on the wholesale side, but now also on the retail side. They have a facility where they will emulate the power grid. They basically try to make this look like an actual home and actual consumers. A lot of it is done through simulation and computer modeling, but they're tied into the power grid. They've combined, in this case, a small solar facility with battery storage and with controllable loads. So those loads would be an air conditioner, television, washing machine, everything you would be using in your home, a diesel generator, as well as a 5 kW fuel cell. The important thing with these projects and this testing, it's threefold. First is to try to calculate what the costs would be for such projects. The second thing is to prove that you can combine effectively both traditional power generation and renewables and have it match comfortably with what the end consumer needs in terms of their usage. But then third, and again most importantly, and I again stress to keep this in mind, the stability of the grid is always key, always paramount. Any idea that you come up with, if it in any way interrupts or causes anyone to think that it might cause problems for delivery, distribution, or on the grid, probably won't be accepted. So it's something to keep in mind. Okay. So there is a cooperative, in the US there's a large municipal utility network, and they've all come together and they have started to pool their resources. And they have quite a large number of projects that they're working on. Some of them work only in some of the very specific technologies that we showed you a little bit earlier. Some of them are working just on, say, fuel cells. Some of them are working on just plug-in hybrid cars. Many of them are integrating multiple technologies. They're looking at, and again, this is, I think, quite useful for you to consider, short duration needs. So that would mean on the power grid, if you start up, say, a motor, and it causes frequency modulation. Ramp requirement of renewables, again, in the morning as solar starts to come up and wind is intermittent. But also in the long-term duration needs. We talked about demand response just a moment ago. Storing renewable power, that's a very large new industry. We talked about batteries, but I'll also mention that there are lots of different ideas around the world as to how to store energy. It's I think from the scientific side, it's a fascinating idea. It has to store energy, but also it has to be cost effective and efficient. So one of the interesting ideas that has come out of both the US and Europe is the idea of power to gas storage. This would utilize overnight wind energy to create hydrogen from water, store the hydrogen, then utilize the hydrogen either directly into the gas supply at say 5 or 10%, or a little bit less efficient, utilize the hydrogen directly and again for power generation in a gas plant or through a fuel cell. Again, these are technologies that are being tested. A couple of years ago didn't exist at all. And that again is to say that batteries are not the only storage solution. If you come up with a good battery solution, wonderful, but there are many, many other opportunities that the market will accept because there's no standard yet. Okay, the Pacific Northwest grid is, again, quite a lot of utilities that have come together. This is a very large test. BPA is Bonneville Power Association. It's an organization that's on the West Coast in the U.S., federally owned, with 12 other utilities. It's a very large test because they have 60,000 users. And I suggest if you're interested in this area at all, it's probably something worthwhile looking at. So this goes everywhere. The $200 million project goes everywhere, again, from smart meters, which is first and foremost, but also in smart buildings. And looking at, again, demand response and load response, so that if they can avoid building a power plant by managing consumption in a building or in a home, it's very efficient, and that's where they want to go. They have 12,000 smart grid assets, so that means everything from solar and water heaters, appliances, battery storage, plug-in hybrid, and backup generators. So let's go back, when we say smart appliances, to the example of the toaster. If you think about what that toaster is, we had sort of made a small joke and said, well, it's really an energy consumption box that happens to make dark bread when you need it. But if we look at all of the appliances in your home, a toaster is one that's high in energy consumption, but your water heater is also quite high, your air conditioner is also quite high, and a dishwasher is also quite high. Refrigerator as well. Could be some hundreds of dollars per year, depending on how you use this, in terms of just electricity cost. The consumer is starting to understand these costs better. Obviously, they want to be green, they want to reduce consumption, and they want to save in terms of energy. So part of this project is looking at controlling appliances in your home. Air conditioners are one of the easiest because they're usually used when there's the least amount of electricity available on the grid. So there are controllers that are connected to, in this case, up to 60,000 users, where if the utility decides that the ability to provide electricity is low, they'll shut 60,000 air conditioners off at one time, which is, I think, quite amazing. There are different models as to how this should work. Some people are very adamant they want to be able to switch it back on again, which I think most utilities are agreeing with. But again, just that communication tool to be able to, from the utility side, go into the home and manage these tools and manage your appliances, I think is quite interesting. So again, back to the toaster. There's another financial model that's starting to come up that says, well, if I sell you a toaster or a washing machine or something else, and I save you 50% of the electricity cost, that could be $200 a year on a dishwasher. Or let's say, well, let's go back to the toaster. Let's say it's $80 a year in cost. Well, the toaster is 50% more efficient. The user now saves $40. The concept of giving the toaster away for free is now possible. I'll repeat that because it's not intuitive. Imagine a toaster manufacturer giving the toaster away for free. In return, the consumer saves $40 a year in electricity, and the toaster manufacturer makes $40 a year every year from that one appliance that he sold. Yeah, that's not an easy thing to consider, and it's not widespread at all. But it is the way that the market is going. We talked about demand response. People in the US are being paid to reduce their consumption. It's because the utility has a huge need. It's only a matter of time before appliance manufacturers, before hybrid vehicle manufacturers and electric vehicle manufacturers start to understand the value of the energy they're providing, especially if it's green. In many cases, the cost of the electricity and energy is much more valuable than the product that they're selling. The other example I'll give you, just for what it's worth, photovoltaic sales in the US, a lot of it is based on free panel installation. And then they share the cost of the electricity at the end. So a lot of different interesting models along those lines. Okay, this is one I was involved in more directly. This is quite interesting in that they actually built, in this project in New Mexico, they actually built a new home as part of the test project. And it's connected almost all of the technologies that we had just looked at. This is a very expensive project. I think by itself, again, about $80 million. Half came from Japan, half from US national laboratories and local government. If you're interested in these areas, again, my apologies, we don't have a lot of time today. But if you're interested, I want to show you what does exist. And there's lots of information on the web where you can contact me to talk about this as well. And then some final thoughts just to try to wrap things up and summarize. How do these projects occur, whether it's a smart grid project or a green building project? They occur with close cooperation between the stakeholders. That's the utility company producing the power. It's the technology provider, whether it's software or batteries or fuel cells or PV. The consultants and the people that are actually installing these things. And then very, very important, the end user. If the end user doesn't like the product, no matter how green it is, they won't use it. And I think Mr. Moon said this very, very clearly and very well. If it's green but too expensive, no one will use it. If it's green and inconvenient and not useful to the end consumer, no one will use it. So buy-in and involvement of the power utility, very critical. Whether it's a green building project, again, or a smart grid project, the utility always controls, at the end of the day, the supply security issue. If the utility is cooperating and you can explain to them how it's useful to their customers and how the utility benefits, you can go forward with your project. If the utility becomes an enemy or skeptical of your project, it won't happen. They always have the final say. Okay, number 3. For these large projects, there are so many technologies. So many of them are, I have to say honestly, maybe wasting some money. They haven't defined very clearly what their goals are, whether it's to reduce financial cost, whether it's more leaning towards proving that green energy will work, or whether it's a supply security issue. Well-defined, very clearly defined project goals will make your project very, very much more successful. Project size is not that important. You can do a tiny project. Their lab, as well as Technical University Berlin and a lot of universities in the US, have very small test projects. Very useful. It doesn't have to be huge. Number 4, this is something that in many parts of the US for green building and smart grid, the utilities tend to say if they put in a smart meter, they've done enough. That's it. Smart meter means smart grid, it means intelligent. I think you now are in a very good position to explain to anyone that says this, no, it's wrong. It also includes power generation, you know, right? Wind and solar, traditional power generation, the grid, the communication systems, the green buildings, and everything else. The smart meter, it might be a starting point, but that's really just the very first point. And I think hopefully all of you now will be able to explain this to people when they say, we're installing a smart meter, it's now a smart grid. Maybe not. And then finally at the end, software is a really key factor. We showed with the Nest computer, it has a handheld app. Hardware is always critical. Efficient hardware will always make for a better product. But the ability to control those products, really good software that makes things really easy for the end user, Those energy management systems, when they're easy to understand and use, make a really wonderful addition. I'll give you one last example. Green office that's close to my office. They spent a lot of money to retrofit. It has LEED Platinum status. Very beautiful office. They couldn't control the thermostat very well and the climate controls. So they spent millions of dollars making this beautiful office, and then the employees would just walk over and open the windows whenever they weren't comfortable. So just again, one last example to say the hardware is important, but all of the controllers and all of the software as well will be important for you. So thank you very much for your time.